Hello, everyone. A warm good evening to all. Thank you for joining with us today. We'll wait for a few more minutes to let other people join so that we can start our session. And thank you. I request everyone to be on mute, keep your microphone mute so that we will continue this session very smoothly. Thank you. Hello, everyone. Good evening. I'm Navya, customer success team here at Spectransis. We'll wait for 2 more minutes and we'll join. We'll start with our session to let other people join. Thank you. Hello, everyone. Thank you. Thanks for waiting. I am Navya, Customer Success Executive here at Spectransis. Once again, a warm good evening to all, good morning, and good afternoon, since everyone is joining from different regions. Thank you for joining with us today for our webinar Beyond Vibration Why Ultrasound Should Be in Every Plant's Reliability Toolbox. And I will be hosting you today along with our speaker, Mr. Kotia Nayak. So, before getting started, I just wanted to give a brief intro about Spectransis. So, let's get started. At Spectransis, our vision is to bridge the skill gap, help individuals to find right opportunities, and connect organizations with the right talent pool. And our only mission is to centered around enabling success by delivering training and innovative solutions that empower individuals and organizations to meet their goals. We are not only the training provider, we are your learning partner. We support growth by offering skill development not only for today but also in the future and with all under the expert guidance. And our focus is to empower core professionals. Here, a new word which is we found core refers to condition monitoring and reliability engineering, best suitable for all our professionals. And I hope you will be very proud using this word in your career. As I said before, we are not only the training provider, we are we do also provide career assistance where we help every individuals and find right opportunities and connect employers to the right talent pool. And not only this, we develop skills for now and the future under providing a holistic learning solution under the expert guidance. And not only this, we are also we providing networking. We believe when people come together as a community so that they can share their knowledge, skills, and resources. And coming to our training programs, we do provide trainings in condition monitoring, which comes vibration analysis, ultrasound analysis, thermography, and other technologies, asset reliability. And this is a great growth path for asset reliability advocates to become leaders by taking advocate course, practitioners course, engineer course. And maintenance management, which comes under dynamic balancing, shaft alignment, and other trainings. And along with this, we are also offering some of the oil and wear particle analysis with fluid lubrication analysis and wear particle analysis courses with the some of the NDT technology courses and also some of the CAD CAM mechanical designing courses. And as you know, we are the exclusive partners with the industrial press where all our materials print. You can also check out our website. And also, right now, we are offering a special offers on our books. And as you know, we are the principal partners with the Mobius Institute and also with the Trexet. And coming to our delivery model, since we support learning in your own way, we do provide instructor led courses, like we do conduct instructor led courses where you can visit our training center and have the training or join via live virtual to get the better interaction and engagement, which create effective learning. Or you can have our instructor at your premises and have the training. If not both, we do also provide online learning, traditional e-learn courses, which is iReliability Learning Management System courses. And the main part comes here is how can we add value? How Spectances will be adding value? So as you know, our instructors are the industry practitioners. So like their personal and professional experience bring the courses to the life. And as you see, all our instructors are having around decades of experience. And we support learning in your own way. As you saw our implementation and delivery, we have flexible training delivery model that suits your learning style. And also we do provide our all our courses with the best pricing to continue your learning. And not only this, we do also provide consultancy services beyond training to solve critical problems. And the main part is we are the pioneer in the training delivery. As you know, we started all these trainings and certifications in India. And apart from our commitment, we also elevate your career. We built an application that connects aspirants and employers. So, this ecosystem is a gateway to career success and talent pool. By facilitating this connection, we created a win win scenario for both the parties. Like We enable individuals to find the right opportunities and also employers to connect with the best talent pool. You can have individual accounts for the both aspirants and the employers, which is completely free of cost. This application feature includes learnings, book your trainings, events, blogs, and many other things. And also, I would like to suggest you explore this application right after this webinar so that you're also get an idea like what do we provide and what the opportunities we do provide. And apart from our commitment, before we dive bigger, I'm excited to share something special we have been working on, that is Core 2025. It is happening from 26th to 28th November 2025, and it is going to be a powerful platform where professionals come together to share their best knowledges and learn from industry leaders and most importantly build meaningful connections. The goal of Core 2025 is very simple. We help you stay ahead in your career, explore the latest technologies, and interact with employers and peers who are just passionate about reliability and maintenance as you are. So, whether you're looking to sharpen your skills, get inspired, or simply connect with like minded experts, this is the event you don't want to miss. And you can check out more details on our website at www.spectansyscore.com, and we will be very happy to help you get the registrations when you are ready. And thank you for listening to me. Thank you for your time. You can reach out to us anytime. We are here to support you and we are here to help not only now but also in the future. And from now, our speaker, Mr. Kotia Nayak, will be taking over. Over to you, sir.
Okay. Thank you, Navya. Thank you so much.
Thank you, sir.
Yeah. Hello, all. Good afternoon. Good evening. And I'm sure, like there are very few people from the Americas, but a lot of people from the Europe and Middle East and Asia regions. So good afternoon and good evening to all of you. Thank you so much for taking your time to join this webinar. I hope you'll find useful and some takeaways from this webinar, today's webinar. So yeah, we already delayed. So let's get started with this. So I'm sharing my screen. Hope you are able to see the screen. So let me know any issues, Navya and Ashok. So our team, Navya and Ashok, is here to support with any questions or if you have any queries or any further, and we can support you with that. And I guess you can type your question in the chat box where Ashok will help in clarifying or, translate that, and then we can get back to you. Okay. So once again, thank you so much for joining today. And today's webinar is slightly beyond the vibration. So what are we going to discuss? Why ultrasound should be in every plant's reliability toolbox. Okay. And what are the strengths of ultrasound? We are going to discuss more focused on that. And we have been, doing vibration and other technologies. Maybe, some of you have been, certified vibration analyst, or maybe, the thermography, or maybe oil analysis, or maybe other, the motor current, or maybe, the other technologies where you have an expertise. But today we are going to more focus on the ultrasound. Maybe some of you are using the ultrasound. What is its capability, and how does the ultrasound is going to help in plant reliability improvement? So we are going to discuss that today, and make it more interactive. You can type your questions in the chat box. We'll get back to you with those questions, answering those questions. And also, if you have any other queries, please reach out to us. We'll be able to clarify those. Okay. Yeah, let's get started. And yeah, some of you know me and myself, Kotia Nayak. I have over 20 years of experience in condition monitoring and reliability. I'm an instructor for condition monitoring and reliability courses where I used to deliver vibration courses, reliability courses, and also some of the other technology courses like the ultrasound and other courses, and also some of the corrective maintenance courses like institute dynamic balancing, laser shaft alignment, and few other courses. So yeah, I'm a certified vibration analyst and reliability expert. So reliability, the expert in carried out, the some of the reliability works and reliability courses where we deliver ARP courses like reliability advocate, reliability engineer course, and various other courses. I worked with the SPM, SKF, Mobius Institute, and last employment was with the Mobius Institute as a training partner manager and business development manager for Asia and MENA region. And now with the Spectransis as a director and also the lead instructor, where I'm responsible for technical works. Okay. Yeah. Today's webinar agenda, as you see here, challenges and maintenance, and overview of condition monitoring tools. Some of the tools what we regularly use: vibration, thermography, oil analysis. Some of these tools, how these tools helps in, and also talking about ultrasound and comparison of the technologies, ultrasound versus vibration versus infrared, what each of these technology, how these complements, and also key applications of ultrasound. How does the ultrasound helps in various applications that we are going to discuss, and also one of the case study, and then we'll open for the question and answers. We will discuss if you have any specific questions, and I will discuss those. Okay. Yeah, let me enable my pen also so that if something is required to write on the screen, so it will help me. Okay. Yeah, let's study. Sure. Yeah. Okay. So yeah, we'll be talking about all these things now. Let's get started with that. Challenges in maintenance. So anytime have you heard these words like the machine was running just fine yesterday and it was good, and all of suddenly it has failed. Okay. So from maintenance team, or maybe from your some of the operations team, you might be hearing this, and then it was good until yesterday and suddenly stopped in the middle of the production, middle of the operations. So something it has broken, something it has caused. And also and plant manager, or maybe the senior manager, or senior management would be thinking that now we are losing lakhs every hour because of this breakdown, because of this unplanned shutdown, and also this spare won't have the available for 3 more days, or it takes time to get the component for the replacement, and it's now every hour we are making loss, and the production loss, and also these are the, as you see that these are the today's realities. It sounds familiar to everyone. So this is what we hear from the manufacturing plant, or maybe some operational plants where we see. And despite having all experienced professionals in the industry, technicians and managers, maintenance managers, still we find the gaps, still we find the problems. So like increasing the maintenance cost, and also the machines are breaking down, and also some of the repair costs which are very expensive. So this is what we hear from the maintenance. This is what we hear from the the many industries. Correct. So this is what it says. Then this gives us an importance of having a condition monitoring and to understand what is going on with your rotating equipments. This gives they can gives an importance of the condition monitoring. Let's discuss like why the condition monitoring is important and how does the condition monitoring it helps. So as you see the industry, the cost of unplanned failures, okay, equipment breakdowns lead to production loss, safety risk and costly repairs, and even the downtime can cost thousands to lakhs per hour, depends on what type of industry it is, whether it is oil and gas, cement, power, or whatever it is. So the cost of unplanned failures are really unbearable. It's very expensive. And traditional versus predictive, like we are all aware that traditional is kind of reactive maintenance. How does it the work? So fix it after failure or fix after failure. So like until then, we keep running, and then once it is failure is going to happen. At what extent it is going to happen, we don't know. That can lead to an even secondary damage and lead to an the safety and other issues, high risk, high cost. And where predictive can help, it detects the early sign of faults. Okay, so it detects the early sign of faults, especially talking about vibration, talking about the thermography, oil analysis, any techniques. It helps us to understand what is it in it and how it is going. Based on that condition, we take some scheduled repairs and optimize the uptime. Basically, improving the uptime so that it's not break down to the equipments. And also need for an early detection tools. The early detection of the fault helps us in planning in advance, like more repair options where you can plan for especially the schedule and resources management, and also with the better planning you can lower your cost. Okay, so what are the technologies are available for early detection? Okay, we all much aware that vibration, infrared, oil analysis, these are technologies which helps very well. But what about the ultrasound? So is that ultrasound is also going to be helps in finding the faults early, helps in finding the faults in early before they becomes an problem. So how does the ultrasound, where does it fits basically? So is similar to the vibration and oil analysis and infrared technology, or is it something different? And that's what we are going to explore today. So as you see that we'll come up with some the interactions here. So let's understand what condition monitoring tools are you currently using at your plant. So you can put it in chat box, or like you can, our poll also will come on the display. Ashok, can you pull the poll?
Yeah, the poll is live now, so they can answer their questions through the poll using this poll option.
Okay. Yeah. So poll is open, and then you can give your answers so that we understand better, like what condition monitoring tools are you currently using at your plant? Vibration analysis, thermography, oil analysis, ultrasound, or mix of one or two. So what are your strategy, or what is your currently, what tools you are using?
We have a limited time, so I request everyone to poll their answers through the poll option so that we can validate and we can continue further.
Yeah. So even you can give in chat box also.
So we have mixed answers, sir. So we are receiving mix of all 2 or 3 tools.
Okay. Mix of tool. Okay, good. So as I see here, approximately 54 percentage, or above 50 percentage, or mix of tools, that is the combination of ultrasound, or maybe the combination of vibration and oil and ultrasound. Could be one or two ABC. Some of them have given ABC. Some of them have given ABD. Some of them given like different the answers. Good. Yeah. And today we are going to discuss that it's not going to not every problem is going to be detected by a single tool. So every technology has a certain limitations that we will discuss today as well, like what are its limitations and all. So is that good? We can go ahead now, Ashok.
Yes, sir, we can go ahead.
Okay, so it's overall now, yeah, there are some, many of them are okay, that is the mix of technologies or mix of tools where they have been using. Okay, very good. So typically, as we see in industry, the standard reliability toolbox is combination of these, like vibration and thermography, and sometimes the vibration thermography with the oil analysis, sometimes vibration and motor current for electrical assets. Okay, and as you see, out of all these techniques, like, and maybe the other technique which is going to add it up. So vibration is very popular, as we see that around 70 to 80% of the faults, rotating machinery faults, can be identified alone with the vibration analysis. That's why it is more popular technology. And as you see, some of the other techniques where equally contributes. So infrared thermography, oil analysis, and but what about the other technique? Is your toolbox incomplete, or is your toolbox something missing? So is this only every problem in rotating machinery is going to be only R in your entire plant? So is going to be only vibration, infrared, oil analysis, and motor current? Or is there any other faults which can be, any other techniques which can help? So yeah, that's where, comes the ultrasound. Ultrasound is going to be really, it's a good technique where you can see about, ultrasound. What is it basically? Ultrasound involves high frequency sound waves, which is about 20 kilohertz, which humans, can't hear them as you see them. So if it is like these sound waves, or the waves, if we classify them, so the waves which are less than 20 hertz, it's called infrasound, and 20 hertz to 20 kilohertz, it's called ultrasound. This range, okay. And then like you have an ultrasound power, so like up to an 1 megahertz and above 1 megahertz is going to be ultrasonic diagnostic. What do you mean by basically ultrasonic power and then diagnostic? This is going to be mostly for the applications where industry uses, and this is for ultrasound imaging purpose. It uses imaging, like as you see some of the ultrasound imaging also. So the imaging purpose, even very high frequency, it's going to be beyond the 1 megahertz. So it's going to be very high frequency. And for a regular diagnostic purpose, sorry, the regular problem analysis purpose, we use ultrasonic for the waves, which is going to be above 20 kilohertz. The most common frequency in the usage is the 40 kilohertz. Okay, so 40 kilohertz is the most commonly used frequency band in the ultrasound is the one. Okay, that's the ultrasound. So the human hearing range is like 20 hertz to 20 kilohertz, where we can hear any sound which is making by, can be any of like the vehicle is passing through that, or maybe any impacting is occurring. So any of those like within the range of 20 hertz to 20 kilohertz, and beyond the 20 kilohertz, really our hearing capability could not make it. So those waves basically, as you see here, so this is like it's time, nothing but t, and f is equal to 1 by t. So where you see that the timing is shorter, it means the higher the frequency. Usually these frequency, as you go higher the frequency, their amplitude level will be very smaller. Okay, their amplitude levels will be very smaller. It means, so this indicates your amplitude and this indicates your frequency. So amplitude, when it becomes smaller, and we lose our capability to hear them. Okay, so it means we can't hear them. Basically, they are very quite an low amplitude signals, which we can't hear. That's where we need some assistance. We put in headphones, and then the headphones is not just making you to hearing. There's a process basically converting those high frequency signals into an the audible range. That's process called heterodyne. Okay, when you do the heterodyning of the signals, converting those high frequency signals into a low frequency where it is an audible range, so which falls under the range of 20 hertz to 20 kilohertz. How we are going to do that? It's more of little bit technical, what we work. So they're going to be one, basically the carrier frequency is going to be like, you're going to interact with the frequency. These two frequencies, the one low frequency interactions will be there with the high frequency. When you interact two frequencies, the sum and difference of these two frequencies. Say, for example, you have a 40 kilohertz signal you want to hear. Then what do you have basically? You and interact with the another signal. So say, for example, 30 kilohertz signal, you will interact with them. Okay. So 30 kilohertz and 40 kilohertz, the sum and difference, sum of these two frequencies is going to be 70 kilohertz. And then difference of these two is going to be, 10 kilohertz. Okay. So the 70 kilohertz falls range of beyond the human hair again, somewhere here. Then, the different frequency somewhere falling within here. Then what happens, the 10 kilohertz, we are able to hear that. That's, the heterodyne process where it works inside. And then those inaudible sounds makes you to audible. That's what, where you are, the ultrasound is going to work. Okay, and that's where you are able to hear the sounds within the 20 hertz to 20 kilohertz. So how these waves are being produced? These waves are being produced from the different applications. Can be the rotating equipments, can be from the compressed air, or it can be from the electrical leakage, or can be mechanical impacts. So these are wherever in your process applications, when you are the operational applications, wherever we have the friction, turbulence, and impact. So like friction, turbulence, and impact, where those minor frictions, very low low amplitude, high frequency friction, turbulence is happening. Something is leaking, whether it is a vacuum leakage or air leakage, compressed air leakage. So something is leaking. So then it creates a turbulence. So the turbulence, and then also anything which is impacting at a regular or interval. So that's impacting, and impacting also can be heard with the ultrasounds. So wherever you have these, the phenomena like friction, turbulence, and impacting, where ultrasound can effectively work, capturing those, the events like frictional events, turbulence, and impact events. That's where the ultrasound it is going to be useful. But how does it difference with the vibration? Vibration is also going to get the same information like impacting, friction. When the bearing is running dry, you'll be able to identify those very high frequency signals and able to understand that what is the condition of the bearing, whether it is a dry running or the or is there any mechanical damage which is causing impacting on inner race or outer race or rolling elements. How does it is going to make difference? Yeah. So that we will discuss. Now, when you come to the, in bearings, basically, if you have identified the impacting or some kind of, the friction, you can hear or you can, observe those events in the vibration, but that would relatively at a low frequency, maybe in range of 10 kilohertz, 12 kilohertz, 15 kilohertz, maybe go to up to 16, 18 kilohertz. But it's very difficult to go up to, as you go higher frequency, the capability of the vibration it goes down. Talking about 20 kilohertz above, 30 kilohertz, 40 kilohertz. It's because the amplitude would be very low and frequency is very high. Then those are very tiny signals which are difficult to capture with your, the vibration systems. That's where, the ultrasound is going to play an important role, especially identifying those faults in early stage. Early stage, like, when the bearing is start deteriorating, first, going to be, kind of a very, very minor friction. So that's going to be at the range of, 30 to 40 kilohertz, where your vibration technology is not effective. That's where, the ultrasound adds value to your reliability program, or adds value to identifying the condition at an early stage. Let's look at that, how the types of ultrasound monitoring, how do we monitor them? So there are airborne ultrasound, okay, especially the applications where you have compressed air gas or, vacuum systems, steam traps, and also, the corona discharges in electrical. So in that applications where we use an airborne ultrasound type, you have a sensor, go and around, inspect the assets where these leakages happening, where these vacuum leakages or compressed air leakages, corona, like arcing happening, partial discharge, those kind of things, where you can identify with the airborne test. There's another one, structure borne, where you have a sensor, you physically, touch the equipment and hear those noise, especially the lubrication problems in bearings, and also, any valve functions, especially the, where you have an walls and the any fluid, the flowing of fluid systems, and also the rotating equipment monitoring, where you identify certain faults with the, the structure bones, where you keep the, the sensor, and then we do an analysis with that, like capturing those and waveforms and spectrum and do an analysis for that. Some of the top application of the ultrasound, as you see, compressed air gas leakage systems. It quantifies the leakage, how much is the leakage which is happening, and we'll be able to quantify that and also estimate the loss, how much we are making. Okay, this is a major applications where ultrasound is going to be helpful, and quantifying the leakage and also estimating, how much is the loss occurring there. And especially in the electrical applications, where identifying the arcing, corona, partial discharge, and all these issues, where you can identify electrical, for the safety point of view, and also for identifying those early fault conditions in the electrical systems, it is very useful. Another application is stream trap. Okay, so where you have, these steam systems, the traps, the steam traps, where, the condensate stream, it goes, the discharges out at every interval. So if the valve passage or valve blockage, or, the any fluttering or any, the things malfunctioning, that can be identified with the structure bone. Again, you need to physically touch the, stream traps and able to identify that. Bearing condition monitoring, so especially for identifying the lubrication condition of the bearing and optimizing the lubrication conditions, precisely, lubricating how much we need to lubricate. And when you are, now the bearing, like grease guns, as you see that it is coming up with the ultrasound assistance, where you can just lubricate, listen to the sound. If the amplitude levels are going down, further pump it, going down, and then, listen for some more time, pump it further. When it is increasing, that means you are added a sufficient lubrications. Now you can, remove off your, the grease gun. So that gives you, the optimum lubrication to your bearing. Not excess, not under lubrication. This is one of the major failure in the bearings. So the lubrication is almost like contributes to 50% of the failures of the bearings, where ultrasound can help you in precisely lubricating the bearing. What is the quantity it is needed? Not excess, not under. Okay, and these are the top applications of the ultrasound, where it can help in all these areas. compressed air leakage, electrical faults, steam traps, bearing condition monitoring, as well as precisely lubricating. And this is a must requirement, or it is a must for every plant. You have an compressed air systems mostly every plant, electrical systems in every plant, steam traps almost again that's going to be in some applications where it is more useful, but in every plant it is going to be. Bearing condition monitoring, especially understanding the lubrication condition and the deterioration, monitoring with that, identifying the bearing at a very early stage is every condition monitoring requirement, and precisely lubricating to ensure that optimum lubrication for the bearings to avoid the the under and over lubrication of the bearings. This is very important. So in every application, it is going to be very useful. So it's more versatile, easy to use, and affordable. So that's what the ultrasound specialty. Coming to that, comparing the technologies here, let's break it down to every tool in your reliability program brings a unique strengths, as you see, but none of them do everything. No, one technology or one tool cannot help in every situation, cannot help in everything. So if you look at that parameter wise, like early fault detections, that goes very well with the ultrasound. Leak detections, where your vibration analysis cannot work. Thermography, it helps. And similarly, where you have an ultrasound is going to be very useful. Electrical faults, before it becomes major fault that can be identified you with your infrared. Before that, you can identify with the ultrasound. Again, it is a very early systems. Steam traps, again, ultrasound, it is going to useful very very well. And lube optimization, lubrication optimization, where your ultrasound is going to play an very important role. In all these applications, the ultrasound technology plays a very important role. Okay, ultrasound doesn't replace other tools; it enhances and completes your reliability strategy. So it's not just tool; it's an improving your reliability and performance. It's a strategy for strategic value addition to your current condition monitoring and reliability program. Okay, so now the question time. Which technology do you think detects bearing problems the earliest? So maybe some of you are using vibration, oil analysis, thermography, and ultrasound. Which technology you think it identifies at an early stage? Vibration, oil analysis, infrared, ultrasound. Good. Good. Meaning ultrasound. Yeah, as we just discussed, ultrasound really identifies the bearing condition very early stage. So as we mentioned, like the bearing failure, it starts with the the minor frictions, like the imperfections in the lubrications, that starts with the minor friction, comes down to lower frequency, and where the subsurfaces and surfaces get cracks, and then where it's going to be having impact frequency is going to be likely lower frequency. Further, it leads to deteriorations and lead to a damage of the bearing spallings and cracks and everything. That's going to be even lower frequency. Then the bearing becomes more loose and then becomes more noisy. Then going to be more at low frequency. So from early stage to the failure stage. So that starts identifying the ultrasound, or using ultrasound can help you in really identifying the bearing condition at a very early stage. Now, yeah, this is the technology debate. So like, who identifies the fault condition at an early stage? Of course, like, so ultrasound, I hear something fishy inside the bearing. So says that, like something more frictional noise can be heard when the lubrication film thickness is getting, decreased. so that you can hear more frictional noise in the ultrasound that can lead to a subsurfaces surfaces crack, or more frictional, the frictional damage, then leads to subsurfaces and surfaces crack, then lead to spalling, and then lead to some damage. Then that's going to be very low frequency that can be identified with your vibration analysis, oil analysis. Bearing becomes more heat, hot, then can be identified with the infrared as well. So, but the first detections is going to be with your ultrasound. Okay. So why the ultrasound is perfect complement? Because where it detects the faults what others can miss with easily. So like identify the early stage issues before the vibration or heat appear, picks up friction, turbulence, and impacting. So that's where, and you are familiar with the PF curve, I guess, where failure begins and then where the functional failure rate happens. So as you see that where the failure rate began here at this point, the potential failure began P, the and to and your functional failure F. So this is called the PF curve. So and this now if you identify the stage at this one, so you have a really good time for your planning. Okay, but if you identify at this stage, you have a very little time for your planning and managing the resources. So if you can identify at an early stage here, so where ultrasound detects a very early stage, so you have a better planning. So that's where your ultrasound is going to help in identifying the fault at an early stage. Okay, so typically we are talking about bearing, the condition, but not just bearing, but even for the other applications also, like we are talking about electrical applications. Initially, the partial discharge, the like baby arcing, we can say that. So when you have identified at that stage, leading to big issues, arcing and some failure, so that can be avoided. Again, in electrical conditions also, it is an very advanced stage of fault predictions. Again, coming to any other applications, if we talk about, so it really identifies a very early stage. Okay, so that's where the ultrasound is perfect, very early fault condition detections, we can say that. As you look at here, the ultrasound is going to play a very early stage role. And ideal for critical and low speed assets. Some of the applications, you are aware that where you have the especially preheater applications in power plants, paper machines, where you have roles and bigger roles where calendar roles, or maybe the dryer roles, or maybe in press part, there are some the press rolls have very less than 100 rpm. How it's a really vibration technology is not going to help. Critical applications like the hydraulic roller press in cement applications, there are many like wind turbines. So there are many applications where low rpm is involved, especially like bearings, where you have running at less than 60 rpm, less than 50 rpm, where ultrasound is going to play a very important role identifying them at an early stage. Walls and other applications anyway, those are very value additions. So coming to like compressed air application is also we discussed. So if you are in the you are in when you are in plant, like how often do you inspect your compressed air or steam systems for the energy losses? Are you doing those really, like and this helps a lot in energy auditing also. So like, are you doing, this compressed air leakage assessment, or, compressed air, losses assessment? Are you doing that? If you are doing, how often you are doing that, like monthly, quarterly, or only when there is a problem, or you are not doing it all, like you don't have any applications for that. So how often do you inspect your compressed air systems, compressed air or leakage systems? Okay, good. Monthly inspections. Okay. Some of them are not doing at all. Okay. Many of them like monthly inspections, but not doing at all. Okay. Okay. Yeah, but I'm not sure, whether you have, applications like low RPM and steam and air, these systems where you have. I'm not sure whether you have those applications, but when, having such powerful tool, we must use it. We must use it for your, the all those applications what we have been discussed. And when there is so much of benefit, having these applications, I think we must use it. And it's not affordable, it's not very expensive, it is very affordable, easy to use, and also it's so versatile. If you have a tool not only just for bearing identifications, it helps in, as we discussed, many other applications. And in most of the plants, all these applications are very common, very common. And tools are very affordable nowadays, as you see that, it's a simple meter, to an, the kind of an ultrasound meter to an ultrasound analyzer, which is, very, the robust system, which has, spectrum, waveforms, and, quantifications and different applications with the different attachments it comes. So for energy, the auditing, and for your, regular abnormal, like regular anomaly detections, it is very useful technique. Now coming to the, discussing about why ultrasound is the perfect complement. So it is essential for the air, gas, and steam systems, identifying the, air leakages, vacuum losses, and steam trap failures, and especially in boiler tube inspections and some of the, the compressed air leakages. As you see that compressor, the compressed air requirement is every plant requirement almost. Okay. And you might see, some compressors are running around and then pipelines are going around. And since the application sometimes is very low, but we may not be bothering much many times. But in some industry, if you look at textile and some other, the gas, the pipelines or gas systems where you have, if those gases are getting, leakage, it's going to be a huge loss for the company. And even for the compressed air loss is almost like, 30% of, your revenue, which is going to be, the loss for the industry. And steam traps, like failure steam traps or passage. So it's going to be again big loss. So it quantifies the loss to calculate the energy cost savings, and it is easy to quantify and then show it to a management, what losses are occurring. And this is the number one tool for your reliability improvements. So air leakages, vacuum losses, and steam traps. And another, perfect combination, perfect complement for guides lubrication in real time. Precision lubrications, and especially that's very important, extending the life of the bearing. You can see that, like bearing, excess greasing or excess lubrications or under lubrication can really ruin the life of the bearings. So it can, spoil the bearing instantly, and also, it can spoil the bearing over time. So degrading over time, if we are over lubricating, or if you are, like an under lubricating. And again, for how much quantification or how much quantity which is required. So we are not so familiar with the, the formulas, what is the bearing size and the speed and all, we are not so perfect with that. But this helps in quantifying that, how, as you put the grease gun, and then when you are lubricating, just listen to the noise, the sound. And then when you are lubricating, obviously, when sufficient lubrication is reached, so the noise will go down. In dB levels also, you can see in the screen. And then noise goes down. And then over time, again, when you are lubricating, it goes further. And then, and now you stop and listen for some time. And when you again lubricate it, if it is increasing the ultrasound, definitely, now you are trying to over grease it, you stop at that point. So when you stop it, so that is sufficient for your lubrication, for your bearing. So that's how the ultrasound assistance lubrication, which is now become very popular, and that optimizes your lubrication and also extend the bearing life. Okay, so overgreasing can kill your bearings. Premature failures can happen. Yeah. How do you currently decide when and how much grease required for the bearing? How you are doing currently, like time-based schedule you are following, or based on equipment, sound or feel, whenever you feel some more hissing noise and high frequency noise, you are going and lubricating, or with the ultrasound assistance tool, what you are using, or you don't monitoring, or you don't monitor precisely. It just follows the as and when required, how you are doing that. Good time-based schedule, many of them time-based schedule. So you have an like GLM kind of things where it promotes the regular schedule where you will be doing that. Good. Or majority of them are like time-based schedule. Okay, 90% is very good. Good. So yeah, I think that's a good strategy, time-based schedule. But if you can use with the ultrasound, that's going to be really helpful. Time-based schedule, you might be following like once in every week or once in every fortnightly, I should do the lubrications, which is good, the time-based schedule. But using with the ultrasound tools, assistance with the ultrasound tools can help you a lot in optimizing the lubrication, not excess lubrication, not under lubrication. So optimized for what it is required for the bearing. Okay, wherever you have this grease systems, grease lubrications, wherever it is required, and try this. And with a very basic tool to a very advanced tool, which is there still in that grease guns with the ultrasound assistance, it's very helpful. And I must suggest you to use this so that you'll really save the life of the bearings and also and optimize the lubrications. Yeah. So those are some of the common applications and advantages or benefits of using the ultrasound technology. Let's discuss about the myths about ultrasound. What are people are thinking, or what many people used to think. So ultrasound is only for leak detection. Okay, people think that ultrasound is for the leak detections, but the truth is not just for leak detections. It's for electrical faults, steam traps, bearings, and lubrications. Okay, so these are, I guess these are every plant requirement, and this not just only for the leak detections. It helps in many areas. Such a versatile tool, so it helping in many applications. I think we must start using it. It's not needed if I have an vibration analysis, or people used to think that I have a very strong vibration analyst and analysis team who has cat 2 cat 3 certified, cat 4 certified. So I have an like very good vibration monitoring program. We don't need ultrasound. Yeah, ultrasound detects issues before the vibration. Okay, especially on the slow speed machines and non-rotating assets where you have infractions, where you have where only 180 degrees only rotation which is there, not full rotation even. In those applications where like slew bearings and in wind turbines and especially in junior bearings and steel applications where you have really this is going to be a complement a lot, where you have low RPM to and no RPM, and where the ultrasound is really going to add value. It's hard to use. This is what people think. It creates a lot of conflicts with the other leakages, other things. Every anomaly has its own pattern. Like in vibration analysis, how do we differentiate the different faults? So using different waveform patterns and spectrum patterns. So similarly, every fault has its unique pattern. Every anomaly has its unique patterns. Where the OEM can help us with the sound library, where you can differentiate each of these. How arcing is going to look like, how partial discharge is going to look like, how friction is going to look like. Like all these, they have a sound library with the years of decades of research with their experience. They have collected those information. I think OEM can help you in getting those the sound library, and you'll be able to differentiate yourself over time. So when you really first time when you use, you'll feel like that every sound looks like I'm hearing same noise, same sound. So first time you may feel like that, but over time when you use it, you'll feel yourself that okay, yes, this is the difference. Okay. So after the lubrication, this is how its amplitude levels are getting reduced, and this is how the waveform pattern it looks. This is how the impacts are looking. When the impacts are looking, it means there's a physical damage in the bearing. Likewise, you can differentiate yourself. Okay. Versatile, easy to use, covers many applications, and where certain other faults cannot be detected, the other technology cannot be detected, and where this tools helps really identifying those faults at an early stage. Yeah. Don't let myths block value. Understand, ultrasound is very simple, powerful, and scalable. Now not only just portable instruments, now with the online systems also which is available, you may contact to any your OEMs, UV Systems, SDT, or maybe Sonatech, or maybe other companies. So where they have the now with the ultra view, or different the even acoustic image, where it can be the identified. So with the image systems is also available nowadays, where you can identify, you can see where the leakage is happening, exactly those very tiny leakages where it is happening, where you can't even the identify with this, you'll be able to see them physically through the systems. Okay. When to use what? What is the practical strategy? Should I use only vibration or infrared or ultrasound? Should I depend only on them? Or how my strategy should be in condition monitoring and reliability? So how my strategy should be? Like, yes, ultrasound, it's like an first alert system, detects friction, turbulence, impact, and early stage issues. Best for air compressed and bearings and electrical applications and steam applications, and especially with the low RPM applications and all. Ultrasound is the first alert. For in-depth analysis, go with the vibration, deep mechanical insights, like all these low frequency faults, unbalanced misalignment, looseness, bearing wear, gate faults, all these can be best with the vibration. And where like visual confirmation is required, where you go with the infrared, where visual confirmation is required. Identify overheating and poor insulations, and especially validating the load, temperature, and electrical imbalance, where you can go with the visual, the confirmations, where you can use the uh, thermography. Ultrasound, vibration analysis, and infrared is a perfect combination for your all the applications to cover in the plant environment. Okay. Yeah. That's how the practical strategy should be. So it should be combination of these. Yeah, as we discussed, why the ultrasound it matters. Ultrasound is essential, versatile, and affordable. Covers many applications, not just for one applications. Covers in many areas. Complements vibration and infrared, not a replacement strategy. Please believe that it's not a replacement strategy. Each tool brings unique value, and where ultrasound fills the detection gaps where other tools can really miss with those, where fills those blind spots, especially in electrical applications and steam applications, and some of the the bearing faults identification at an early stage. And then ideal for early fault detections and proactive maintenance strategy. So it gives an early the detections, which enables you to plan your resources better way. ultrasound is not just a tool, it's a strategy for your reliability, strategy for your performance improvement. Okay, it's not just for the anomaly detection tool. It is part of your the improving the reliability and performance, especially your STEAM systems. You are able to identify those, and mitigating those can make you huge savings. That's where the reliability engineers or reliability program is going to work in minimizing those losses. Okay, so the real results from the field, we are covered. So what are the applications and all? So as you see that some of our partner companies where they have been working with the many customers, and where they shared some of the the insights. So where they identified 30 leaks, they found 30 plus leaks, and which has resulted almost like 6.5 lakhs per year the leakage cost saving, and prevented a lot of the early corona discharge issues. So where they have prevented major electrical failures, and also extended bearing life by like 2 times by implementing the ultrasound technology, where especially on the low speed applications where they really had good benefits. So these are some of the real results from the field. So where this ultrasound technology contributed in many ways for their reliability improvement strategy. Okay, yeah, as I mentioned, ultrasound is not just anomaly detection tool; it's a strategy for your reliability improvement. Yeah, I think hope we have covered basics. What ultrasound can really help, and if you are not using yet, what is the biggest thing holding you back? So we would like to hear from you. Like, is it budget is the constraint, or lack of tool or awareness, or training? Whether you are missing the piece of the training, how this is going to work and all, or something else. What is it holding you back? Lack of tools, awareness. Okay. Majority is going lack of tools, awareness, and training. Okay. Okay. Lack of tools and awareness and training. Okay. Good. So nowadays, nothing is possible, guys. So like, now we have, I'm not sure, any of our ultrasound OEMs are here, but yeah, they are easily reachable. All these major companies are there in India. U Systems, who is pioneer in ultrasound technology, and they are easily reachable, based out of Hyderabad. SDT, again, another company who has presence in India, and Sonatech, they also have a presence in India. So these are some of the companies I know which they have a presence in India and other places. So I'm sure these are the global companies, the MNCs who has a presence in many countries. So I think you can reach out to them, and we can also help you. And these are really good, the tool for the all your plant applications. As you see that, as you discuss many applications, how it is going to be. And I would suggest you to and budget, when you say that few responses I see as a budget also, it's not very expensive tool. It's not very expensive tool. Less than your vibration analysis tool, less than your vibration analyzer. Okay, you can reach out to one any good company at your disposal. You can find them. And training, coming to the training, there are OEM provides the training, and we also provide training. The ultrasound basic awareness course we are coming up, and we have a schedule for that. And also the certification course also we have. Ultrasound category 1 course we are going to offer in the month of August. You can see them. So yeah, so these are just to make you understand, about ultrasound technique and also their applications and how unique this tool is. So if you have any questions, so please type them in question, panel question box, like chat box, and I'm happy to clarify you those questions. And yeah, or you can also disable or enable your microphone, and then you can talk if you want to. Any questions? So yeah, I see some of the questions are coming up. Okay. Okay, so yeah, I see some of the questions here, like how do you diagnose electrical faults with ultrasound? Yeah, how do you diagnose? Basically, like ultrasound, when the very initial faults, especially the baby arcing and like the partial discharge, where you can identify, and that time basically it generates a very high frequency signal. So where high frequency signal is close to 40 kilohertz, something, it generates the signal, where you have the ultrasound airborne test. So it has a different the attachments, it comes with the different sensor configurations. So where it can identify those the waves which have been generated by this anomaly, especially the partial discharge, arcing, corona issues, all you can identify that. So if you want to see those, like really in electrical applications, so where these faults like reproduced by arcing, tracking, and corona can be detected by the airborne test. As you see, this is some of the transformers and insulators for signs of these destructive conditions. So it starts with the baby arcings, like as I mentioned, so like corona and tracking, where you can identify them. Arcing as the electrical flows through in space, lighting is going to be a good example here. So this is some of the electrical, and where you can see them tracking, arcing. Yeah, you have this kind of parabolic shape, the sensor, where it is going to capture from the distance also, and you have a different sensor like this. So this is going to be your like locating the exactly the fault where it is, like especially in the from the outside of the cabinet, where you can check the partial discharge and some kind of any arcing is happening there. So where you can use this, yeah, for electrical applications, transformers, switch gears. Yeah. There are some faults that do not generate heat, and the sound generated can be heard through the so this is where your ultrasound can really help. And some faults which generates the heat, that can be at the later stage, that can be identified your thermography. That's why ultrasound and thermography is a good combination for the electrical applications. Yeah. What is the frequency range for detecting problems using ultrasound? Detecting problems using ultrasound. Frequency range for detecting problems using ultrasound. So it's about 20 kilohertz. It depends on what applications you have, and it can go up to 1 megahertz. Like it can go up to even 100 kilohertz and beyond that also. So it depends on the application where you are using. For in bearing frequencies, could be around 30 to 40 kilohertz. Could be good for indicating of your lubrication condition. And for other applications, electrical applications, partial discharge and all, will be at a very high frequency, above 40 kilohertz, where they are going to be used. Any case study on planetary gearboxes through ultrasound versus vibration? Yeah, vibration can help in gearboxes, but ultrasound even can help in identifying the fault at an early stage, especially if it is a low speed gearboxes and also high speed gearboxes also it will help. And usually it can be identified with the vibration itself because it is not so high frequency and can be up to 5 kilohertz, 10 kilohertz, can be well with the vibration, where ultrasound can add value really if there are any lubrication issues. So in gearboxes, but you need to little bit, trend those values and see, how it is changing over time. So based on that, you can do the analysis. So thermography ISO standards. So ISO 18436-8, I think, is the ISO standard for ultrasound, for thermography. And there are some tables and charts are available for thermography analysis. So I'm not remembered the exactly, but what is the temperature gradients and how do we test them? All these things, going to be an good valuation for the ISO standards, for where thermography can be utilized. Any course for turbine ultrasound? Turbine ultrasound, okay. Turbine ultrasound, maybe not sure like what you are looking for here. Like turbine ultrasound, maybe looking for steam applications. What you are meaning here? Ultrasound Cat 1 and 2 certification bit briefing. Yeah, so like ultrasound certification programs are also available, like Cat 1 and Cat 2. So which is ISO 18436-7 standard, which applicable for, and where you use, there are some chapters as you see here. So in ultrasound Cat 1, so these are some of the chapters covered in the ultrasound Cat 1, like introduction to sound theory, sound propagation of sound, introduction to ultrasound testing, airborne testings, and steam systems, valves, hydraulic systems, electrical application. All application it is going to be covered under Cat 1. So it's very helpful, and this tool is really, like this course is going to have, good recognition to your knowledge and experience. So ultrasound Cat 1. Cat 2 is also available, not with the Mobius Institute. There are a few companies, others provides like US Systems. They do offer Cat 2 trainings, and they do offer the basic training also. Can vibration and ultrasound be monitored in the same instrument or analyzer? Yes. So, but ultrasound tool, which has a basic vibration features, but not like the other vibration tool has a diagnostic feature where the ultrasound tool not having fully the vibration features, but ultrasound and vibration combinations, and there are some tools which is available, and but more focused on ultrasound, less on vibration, and vibration analyzers are more focused on vibration, less on ultrasound. There are some tools now, recent tools, which are able to add additional ultrasound sensor, and then you'll be able to identify certain applications where you can use, but not airborne test, only structure-borne testing. What is ISO standard? What do you mean by what is ISO standard? You are looking for ultrasound. What standard follows it mean? Yes, there is ISO 18436-7. I guess that is for ultrasound. Can we identify the exact bearing fault frequency like BPFO, BPFI via ultrasound? Yes, it's very helpful. Very helpful at an even early stage, like from the lubrication stage to till damage stage, where you can identify with the ultrasound. You just need to apply the filters and able to do, precisely monitor those frequencies.
Sir, we have run
Okay,
out
how
of
do I
time.
identify? Yeah. how to identify the passing in ultrasound, wall passing in ultrasound. Yes, so you can continuously hear the rushing noise. There are some applications, especially in the wall testings. Wall. So this is a normal string trap application. So this is fluttering. This is a continuous passage, open position. So that's a continuous passage, like your open position. So you need to little bit understand the technology, how it is going to be different sound patterns and all. Okay. Thank you, guys. Thank you for joining. I think we can reach out to. You can stop. You can start. Still, you can start, or you can start. Still, you can post your questions. We'll come back to you, answering your questions or emails, and also over the other channels. Okay. Thank you so much for joining today, and it's really good to have you in the webinar. And I think it's a good for weekend learnings. Thank you so much. Thank you all for joining today, and I hope we'll have some time to meet in person, maybe in training or maybe in conference. So thank you so much for joining, and again, the message is, the good takeaway is, for since it has an versatile and easy to afford and easy to use, wherever you have such applications requirement, I would suggest you must use it to take your reliability strategy to the next level. Okay. Thank you, guys. Thank you so much, and have a great evening and happy weekend, and take care of yourself. Thank you. Thank you all.
But there is a small update from Navya.
Thank you, Ashok and Navya. Yes.
There was a small update from Navya.
Yes, sir. So, yeah, exciting news for all professionals looking to boost their maintenance knowledge. So, we are bringing you a beginner course on ultrasound, as Sir said, happening on Saturday, 26th of July 2025. And this is the 1 day session, will give you a solid foundation in ultrasound technology. So, and right now we are also offering a special offer for this course exclusively for our webinar attendees. So you can check out all the details on our website at spectransys.com, or you can reach out directly to us for the more information. And don't miss this opportunity to kickstart your journey in condition monitoring. And thank you for joining with us today. Have a great evening.
Thank you. Thank you all. Thank you, Navya and Ashok. Thank you for your support, and have a great weekend. So here is thank you note from all of us. Thank you very much for having today, and thank you for listening to us.